Welcome to Electronics Specify Insights, the podcast for electronics engineers. I'm your host, Paige Hookway. In today's episode, I'm joined by Valentina Ratner, founder and CEO of AllSpice, to unpack what it really takes for hardware engineering teams to adopt AI successfully. We explore the pressures driving demand for faster, more accurate development cycles, and why jumping straight to tool selection often skips the groundwork that matters most, capturing the design intent and reasoning that normally lives only in an engineer's head. Valentina shares where teams tend to get the human-AI balance wrong and what embedding AI into a hardware workflow actually looks like in practice. I hope you enjoy this episode. Let's get started. I'm pleased today to be joined by Valentina Ratner, who is the founder and CEO of AllSpice. So thanks very much for joining us, Valentina. How are you to start with?
Doing great. Thank you for having me. It's a pleasure. I'm excited to be here and looking forward to this conversation.
Excellent. So before we start, would you mind just introducing yourself for us and telling us a little bit about your background?
Yeah, my name is Valentina. I am one of the founders and the CEO at AllSpice IO, an engineer by training. And I started AllSpice to solve a lot of the problems I experienced firsthand. So my co-founder and I made a graduate school and decided to build some of the tools we wish we had and created AllSpice to give engineers that are building the physical world and specifically electronics superpowers so they can spend less time on the tedious and repetitive work and more time the creative design and the things that really move the needle.
That sounds fantastic. Maybe you could tell us a bit more about, what it is exactly that the company does.
AllSpice is a collaboration, automation, and intelligence platform. So it's a place where electronics and electrical engineering teams come together to bring their words to life. And it helps with the collaboration part of it, writing design reviews, managing issues, release tracking. It has an automation engine to kind of help with all of the known problems with known solutions and help engineers kind of put that on autopilot. And then we have an intelligence layer that brings AI into the workflow. And what the teams really like about Allspice is that all of this lives in one place where the designs and the history live. So kind of bringing it all together and allowing them to build this workflow that ties the different parts of their ecosystem, their eco tools, all the way to their PLM on the other end, and kind of help them bring those into one place so that it has one smooth workflow.
Brilliant. Thank you very much for that introduction. Now, we've got a big topic to tackle today, which is building AI into engineering workflows. So let's start with the big picture. So when you're talking to hardware teams today, what's the biggest misconception that they have about what it actually takes to adopt AI into their engineering workflow?
One of the biggest misconceptions is that AI has gotten so much attention and it's a very powerful technology, but not every use case is a problem for AI. There's certain use cases that are better solved by traditional software like algorithms and deterministic systems. So one of the first things we talked about with our customers is truly understanding what is the use case. Like AI can be very, very powerful, but it's not a silver bullet. It's not a fix it all. And sometimes solving a problem with AI can take longer or be more resource intensive or add to the overall timeline, right? So we have to understand what is the problem, the challenge that we're trying to solve, and is AI the right tool for it, right? And sometimes it's not. Sometimes it's better to address the challenges a different way. But most of we have the privilege to work with some incredible companies and incredibly sophisticated teams that are moving at record speeds. And those teams, what they understand is the differences and they understand how to pick the right tool for the job.
It's actually quite refreshing to hear that AI isn't going to solve all of our problems.
It's it's like some problems have been around for a while and other technologies have been around for a while as well. So AI has its strengths, but it also comes with its weaknesses, right? So being able to know both sides of the equation, and it's the kind of the latest in a string of things, but in it definitely brings power to the teams, but not in every single scenario. So it's not something that you can kind of apply as a blanket statement across everything that you do.
So what kind of pressure are teams under right now that is pushing this conversation that we're having? Why is the demand for faster development cycles and improved accuracy, why is that becoming so urgent for teams today?
The hardware and electronics teams are under a lot of pressure to manage a lot more programs than the last year, create a lot more complex boards and systems, and do it in a fraction of the time, which leaves very little room for error. And when people talk about AI, everyone talks about the models and the software side of it, but none of that leaves without hardware infrastructure, right? So a lot of the customers that we work with is like they are the ones building and powering this AI boom. So the more that there is demand for AI, there's the more that there's demand for hardware devices that power AI, transport AI, physical AI, right? All of these things like infrastructure from networking to like the last next stage of robotics, like AI is kind of creating this hole for all of these hardware companies. And for the most part, they can't keep up with the speed, right? It's like if you had a team last year and then this year you have to do 20 programs instead of 5, and they have to be out in 6 months instead of 18, and you have the same team and the same tool that you had last year, right? It's like how are you supposed to do this? And AI has been growing a lot faster in other disciplines, but not so much on the hardware side. So it's crazy to me that these hardware teams are building the future of AI, and a lot of them don't have AI for themselves, right? It's like they are powering for others and for other disciplines, but when it comes to their own workflows, there's still a lot of room to grow and improve.
Yeah, it's a very good point. And as you say, a lot of teams jump straight into picking a tool, right, before really thinking about what the use case is. So maybe you can offer some advice. What comes before that? What actually needs to be in place before AI can genuinely be useful to an engineering team?
There's two things that are critical when it comes to implementing AI in hardware workflows. The first one is building a strong data foundation. AI and agents are only as good as the underlying data that they have access to. And if your data is incomplete, it's unorganized, it's inaccessible, it's impossible to read, there's only so much that the agents can do. So typically, step one is put in all of your information in a format, in a place that agents can understand. And the majority of the hardware stack is not built for agents, right? Some of these tools have been around for a very long time and they're built and they're optimized for desktop experiences with humans clicking buttons, right? They're not optimized for an agent going in and doing things on their own. So there's a lot that comes to like step one is you have to build the piping and the infrastructure and the foundation, right? So that's things like implementing good revision control, figuring out like what data format you're going to use, making sure that all of the different pieces can come together. Most companies will have schematics in one place and PCBs maybe in the same, maybe in another, but data sheets are definitely in another place and supplier information is another place. And a lot of it actually lives in email or Teams messages or Slack messages, right? And all of that context and all of that human knowledge and organization, it's just doesn't really get captured today. So that makes it really hard for agents. It's like you hear it different ways. It's like garbage in, garbage out, right? So it's like the higher quality of your data, the better the insights and the value that you're going to get for AI. So that's step one. And step two is what we were talking about a little earlier, which is understanding what is a use case for AI, what is a use case for other systems, other solutions, and what remains deeply human, where the engineers need to step in and what is their role as kind of part of this process.
I mean, how can we overcome some of those challenges that you mentioned in step one? I mean, you can vouch for this, that there's a lot of knowledge that lives in an engineer's head, the reasoning behind a decision, not just the decision itself. So how do you get teams to actually write that down or make it visible in a way that an AI system can use?
Yeah. So all of that lives today, it lives somewhere. The problem is that it's in what I call the analog world, right? It's in on those post-it notes and those whiteboard sessions. So the most successful teams that we work with implement a what becomes a self-documented process. So the process of documenting it one way, it's harder than it would have been to just write it down on my wiki, like then it defeats the purpose. So the key is to kind of make the process smooth enough and make it self-documented. That's another change that a lot of our customers we work with kind of go through is the traditional engineering process will be something like you start designing, you come up with your schematic, and then at some point later, maybe 3 weeks, maybe 3 months, you go through this massive review process, and then you write down all of the things. The chances that you remember why you made a decision on day two, it's pretty low. So the idea is to kind of break those massive, big endeavors at the end where you go back and document everything into a self-documented process that is like every time you make these changes, it kind of gets recorded almost automatically for you on the background, right? So you kind of like you set it up at the beginning and then you go with the entire process. So at the end, the documentation is not this massive ordeal or something that you have to rely on your memory, but it's more like, okay, let's just gather all of the little pieces that we already collected along the way and let's package it into something that makes sense at this point.
Why do you think something like that, or why is design intent so hard to capture in the first place? Do you think it's a tooling problem, a culture problem, or something else?
All of the above, it's a lot of on the tooling side, a lot of the teams engineers use today, they're general purpose tools, right? Which make them applicable to a lot of organizations and a lot of teams within those organizations, but maybe not as particularly valuable for electronics design, right? If you're working on a wiki and it's like, well, you still have to take screenshots on your ECAD tool, and then you still have to go and paint and draw little arrows and point at things, right? It's like it just kind of ends up defeating the purpose. So general purpose tools, like they're not specific or kind of optimized enough for those workflows, right? So that's one of the challenges. And then the other, from a process perspective, again, is this idea that it's a little bit counterintuitive, but reviewing sooner and more often actually ends up taking less time than doing one review at the end. So a lot of the teams will, it just feels like, well, running 3 reviews in a row, how's that faster? And it's like, but it actually is. If you look at it, like our most successful customers is like, sometimes they're running 2 design reviews a day, like one in the morning with teams that are abroad, they get a pass down and they get another at night. But it's not this massive 3-week process anymore. It's a very fast paced iteration cycle. So kind of breaking down the like one big task into multiple smaller ones in a row sometimes it does, again, it's kind of a little bit counterintuitive. How is 3 reviews faster than one? But if you look at the data and if you look at kind of how the process works overall, it ends up being much faster for the teams.
And what about when it comes to striking the right balance? And I think this is an important question that a lot of people are asking right now. How do teams find the right balance between AI, automation, and human judgment? How can they figure out where that line should sit with their workload?
I think about it in 3 buckets. Think about what the use case is, and deterministic systems are great for known problems with known solutions. Things that you know what you're looking for, you know what the right answer is, and most of the time there's only one right answer. An example would be something like checking if all of your components are in stock, right? Like usually out of stock, it's a bad thing. Like there's not a lot of ambiguity. You know that you have to check for that. You know the components are, you know who your suppliers are. It may be different from company to company, but you have a very clearly defined problem and scope, and it's something that you want to kind of go and you get a pass or fail criteria. So typically for those kind of examples, we'll recommend teams to set up automations in the background rather than necessarily AI. What AI is great for is interpreting ambiguity, massive amounts of context, and doing things at speeds that will be impossible for humans to achieve. So one example, keeping on kind of the component information, is like verifying the components, the 300 components in your board that are critical against the manufacturer data sheets. So going and fetching data sheets and checking every single page of that 60 or 600 page data sheet and verifying it pin by pin and kind of going through that entire process and understanding the schematic notes and all of these things. It's like that's a problem that we see AI being pretty successful at, right? It's like it's something that if a human was to do it like thoroughly, it will probably take a few days to a few weeks, right? But agents can do it. You can set it up at night and you can go come in the next morning and you can have a fully fledged report and you may have already done 80% of the work for you, right? So those are the type of things that AI is great for. And where humans really thrive is like no deterministic system and no AI is going to invent things. Like it's not going to come up with things that don't exist. Like if systems are known problems with known solutions, AI is maybe the unknown unknowns is really good at highlighting things that are in your blind spots. And humans are great for the known problems with unknown solutions, right? It's like how do we create something new and how do we make design decisions? How do we evaluate trade-offs, right? How do we like sometimes there's not one right answer on how to build a circuit and there could be a lot of different approaches, but that trade-off, that decision making, that intent, that architecture, that's where humans like engineers are great at that. They're very creative and this is like their specialty, right? So it's like the more that you can spend the time there. Those are the things that really move the needle. And then it's about decision making. It's about again architecture. It's about intent, and it's about the things that are what makes engineers engineers.
Yeah, I love that. Thank you. And I'm interested. Have you ever seen a case where a team has maybe let AI take on too much too soon, and vice versa? I guess have you seen teams that have held back more than they need to out of caution that I guess wasn't really necessary?
Definitely both. On the first case, too much too soon. I would say AI is becoming better and better by the day, by the hour. So some teams are maybe trying certain technologies, let's say a year ago, it's like, or trying to force a, an AI solution into maybe the wrong use case is like sometimes we see that they end up spending more time setting it up and the results that they get, and then how much time you have to spend fixing the mistakes that it did. It would have been faster if you just did it from scratch. Like there's no ROI. So if you kind of pick the wrong use case or the wrong level of technology or the wrong time, is like just AI for the sake of AI, right? Like it needs to make you faster or your design's better or save you cost somewhere, right? Otherwise, it's probably not the right fit. And then I've seen some teams going that way. And the on the other side, I've seen teams that they hold AI to an incredibly high bar, and they hold AI to the accuracy and certainty and predictability of deterministic systems where I behaves a lot more like a human than it does like a computer. So it's like saying, and we'll see things where it's like, oh, AI helped me catch like 17 errors, but this one it got it wrong and it hallucinated. And it's like, you see, it's like totally not ready and it's a waste of time. And it's like, if that was a human, would that have been the reaction, right? If you had a junior engineer or an in your team and they did 17 things right and one thing wrong, it's like, would that be like, well, then you're totally not a right fit, right? It's like sometimes people hold the bar very differently and kind of understanding the differences between, again, if you need 100% accuracy and predictability, then you really shouldn't use AI, right? You should really use another system. But where AI is great at is that kind of ambiguity and context, but that also means that it comes with some trade-offs where you may get two responses that look different depending on exactly, or it could be the exact same context, right? But it's really hard to replicate things with AI based on the way that this technology works. So I usually say I hold AI to more human standards than computer standards. And sometimes companies that are in the other camp may be missing out on some of the benefits because of kind of where they expect things to be.
But I guess it's all experimentation, right? It's all trial and error. You've got to find out what works best for you, and I guess each team will be different, as you've said. So, okay, given everything that you've said, once a team has the right data in place and they've captured design intent, what does embedding AI into the workflow actually look like on a day-to-day basis? Is it a new tool? Is it a new process? Is it a mindset shift?
It's usually a combination of all of the above. So most most new tools will come with some version of process change. The ideal is that the process is not disruptive because these teams don't have the room for error. Like nobody has 6 months to not produce any products and sit down and get trained on something new and get up to speed. It's like we have to do that. We have to seamlessly merge into traffic. We have to do this while we're shipping products and while we're getting new things out at the same time. So it the idea is that the process change is not disruptive and that the benefit is there. Again, if you introduce AI, but it's not adding more value than it took to adopt to the new process, like there's no ROI. So typically we'll see like 3 to 10x benefits. It's kind of like what companies want to see and want to expect to say like, okay, this is worth kind of doing and going through the motions. And then the interesting thing is like it's also the friction is it's very temporary with sometimes with some of our customers. It's like even from we'll have a meeting with them and 2 weeks later it's like they can't imagine going back. They can't imagine their life without it anymore in like a very short period of time. So it's almost like the transition pay usually is very temporary. And then once the teams are kind of in the new way, like it's just changes the way that they're operating and where they're spending the time. And again, the ideal reality is like, I believe one shouldn't take the best parts of the job away from engineers. It should take the worst parts of the job, right? So let's give technology the things that we don't like to do, the things that we don't have time for, the things that are tedious and repetitive, and let me spend more time on the things that I like and the things that I enjoy. And I think that that's the kind of where the right balance lives.
Yeah, definitely. And I think a lot of engineering teams will be pleased to hear you say that they can focus on the work that they like to do as opposed to the stuff that they don't. But I guess maybe it's a simple question, maybe it's not. But how does a team know if it's working? What's the first thing that changes?
So when we talk to teams, it's like usually will come down to in our world for AllSpice, it comes down to engineering efficiency, which translates to hours that they get back, that they can do something else. It translates to engineering timelines, like shortening their overall timeline. And it's like, again, programs that they used to take 18 months, it's like they have to go down to 12 and to 8 and to 6 or whatever, right? So shortening timelines and then preventing unnecessary costs. So usually that will come in some version of preventing respins or catching things before they get to manufacturing. Hardware mistakes are really expensive, right? Both from a cost perspective in terms of you have to actually order physical boards, but also from a, again, timeline perspective, like a 4 week delay or respin in an 8 month program, it can be pretty catastrophic, right? So those kind of risks and uncertainty is what, if you can remove out of the process, that's where the teams can truly see the value.
Fantastic. Okay, so for someone listening then, for a hardware team that wants to get started but doesn't know where to begin, what would be the first thing that you'd tell them to do?
Our customers that have successful AI rollouts go through this kind of 3 step process. Step one is one use case, one team, then one use case, many teams, then many use cases, many teams. It's kind of like a roll phase rolled out, if you wish. For that first use case, we recommend to pick something that's inspectable and verifiable. Because AI, it's still a nascent technology, right? Because it has this kind of probabilistic nature to it and not deterministic, is like the first use case, it's something that engineers can still maintain oversight, right? Like, I don't think teams or like companies are at the point that they can just press a button and be like, okay, agent, go do your thing. And I'm never going to look at it again and never going to touch it, right? We can get there. But step one is like, okay, let's have the agents do the work, but let's have humans review it and verify it and check it and approve it and kind of maintain that oversight before we release it. And then over time, again, once you train the agents and you kind of optimize the system, then they can start being more and more independent. But usually the first case is something that the it can have a lot of value, right? It can have a big impact really quickly. And that humans can still kind of have the final say for kind of like reliability and safety and kind of building towards that more independent workflow. So most of our customers, the use case that they pick to start is design reviews, because design reviews, it kind of merges these two things where it's something that all the teams have to go through. It's a very concrete point in time. There's a lot of work and evaluation that is involved that agents can do 80, maybe 90, and maybe 95% of it, right? But then the humans can still come in and check the agent's work, and you have to be able to kind of review that and verify it, right? Maybe the first design review, you go through every single comment twice. And maybe the second one, right? Like it's a little bit less because you give the agent some feedback on the last review, and then it becomes less and less and less. So usually that's a great first use case, because it kind of combines those two things. And then doing it with one full team is usually where we see there's a lot of AI MVPs out there and a lot of teams building MVPs, which is awesome that AI is giving this opportunity to like anyone can build anything, right? In like a few hours or a few days. And then put an MVP, right? So usually from MVP to I'm gonna trust it with my crown jewels, my critical designs, my regulated, my aerospace, my rocket controllers, right? Like all of these things is like that's a big difference. So making sure that you can kind of get one use case to 100% to the level that you need it to be able to trust it with production, rather than a lot of MVPs that it looks cool, but I'm not ready. It's like, oh, this looks awesome, but I'm not going to actually trust it with my designs, or I'm actually not going to use it for my production environment. And then it just becomes an experiment rather than like a production grade, like workflow upgrade, right? So that's where we see kind of like the difference is like, okay, once you, and a lot of the teams will try and experiment with a lot of different AI approaches, right? And it's like this divergent phase where we try the in-house, we try the outsource, we try the point solution, we try the best in class, we try the up and comer, we try like all the well, then they start converging, because to maintain again production level systems, you can't support everyone's individuals MVPs or test or evaluations. You kind of have to start. We're going to get one through to 100% to be able to say, hey, this is going to be production level, and we're going to use it for our critical and our real designs.
Great. Some perfect advice there for our listeners, and I know they'll appreciate that. And I have one final question for you, which is sort of looking ahead, I guess, in 2-3 years' time. I mean, what does a hardware engineering team that's fully embraced everything you've been talking about, what does that team look like in the future?
Yeah. I think it looks like never having to pay for the same learnings twice, right? If you learn something in a program, if you it's like we hear a lot of like, oh yeah, like that thing bit us in the past and then it happened again, like things get lost through the cracks, but it's like turning all of those things into living institutional like knowledge and memory, right? Like not having to pay for some learnings more than once. There's always going to be learnings. There's an intrinsic iteration in R&D. Like I don't think that's going to go necessarily away, but anything it's a known problem, right? Like we can address, and a lot of these blind spots can be surfaced, and a lot of these things can be used across programs. And I think that it's spending less time on the things that, rather than drawing lines on a screen, is having a team of agents that does it for you, right? And being more of the architect and the orchestrator versus everything else. So I think it's going to be spending a lot less time on things that just have to be done, and spending a lot more time on the things that are helping us create amazing new technology.
Well, you've certainly made the future look very bright, and I certainly hope that that's the case, and it does seem like we're heading in that direction. So thank you very much for your insights, Valentina. I know our listeners will have appreciated your thoughts, and certainly the advice that you've offered as well. And guys, if you would like any more information, obviously feel free to head over to AllSpice website, and I'm sure Valentina won't mind if you'd like to reach out to her as well if you've got any questions. But yeah, an exciting space to be working in, and I'm looking forward to seeing how AI progresses and letting engineers loose on being innovative and creative. So thank you very much for your time, Valentina. It was a pleasure speaking with you.
Thank you for having me. I really enjoyed our conversation.
Thank you for listening to this latest episode of Electronic Specifier Insights. Don't forget to subscribe to the series to keep up to date with our newest guests, and do share with fellow colleagues, friends and family who may be interested in the latest news from the electronics industry.